Let's now talk about the idea of an odds. We will be dealing quite a bit with odds ratios a little bit later because it's a very nice way to do some inferential statistics. But let's start with the idea of a simple odds. Now the definition of an odds is simply the probability the event will occur divided by the probability the event will not occur. That's what the definition of an odds actually is. Now mathematically, this is the theoretical probabilities. Say pi is the true probability that it occur. That means 1 minus pi must be the probability it will not occur, because only two things can happen. Either the event occurs or it doesn't. So this would be the way of calculating an odds that something is going to occur. Now, when you actually get this number, it could be a number like 1.72 or something, which would mean the probability that does occur is much bigger than the probability that it doesn't occur. So we'd say the odds is 1.72. Now, actually, what this really means is 1.72 to 1. And quite often, we should just write it as 1.72. The 1 is understood there. That's saying for every 1.72 times something does happen, you'd expect it to not happen once. Well, if it makes you feel better and it's easier to interpret, if I multiply both sides by 100, I get for every 172 times it does happen, multiply this side by 100, it does not happen 100 times. These are actually saying the same thing. The question is, which one of these is easier to interpret? Traditionally, we tend to use a smaller number like this, but there's absolutely nothing wrong with doing that. I think it's more of a personal preference sort of a thing. Now, let's go on to an example here. The probability to observe only one head when tossing 3 coins is, well, enumerate the sample space and figure it out. We actually did that earlier in an earlier video. Just as a reminder, we did that tree diagram, the heads, tails, and then the heads, tails, that sort of a thing. We did that earlier. And if you look back or if you re-enumerate it, and actually it's probably a good idea if I pause this and enumerate it again just to get practice in doing it, what you'll see is that there were 3 ways out of 8 to get one head in 3 tosses. So the probability is 3 out of 8. This is the probability. And obviously I'm talking theoretical probabilities here. So what does this mean in terms of odds? Well, it happens 3 times, correct? Well, how many times did it not happen? Well, if you toss it 8 times, it happened 3 times. That leaves 5 that it did not happen. Well, if you do this by this definition, you would have 3 over 8 divided by 5 over 8. The 8's cancel, and you get 3/5. Now, here's where it can get a little bit tricky, but there's a couple ways you can do this. If you actually reduce this or turn this into a decimal, you'll get 0.6. This is actually then 0.6 to 1. Now, this is accurate. There's nothing wrong with this, other than the fact that I think it's pretty confusing. So my tendency here would be to, rather than writing the odds as 0.6 to 1, I'd write it 3 to 5. To me, that makes a lot more sense. It's much easier to interpret. This is saying for every 3 times you see a head, 5 times you don't. That's a single head. So this 5 will represent no heads, or 2 heads, or all 3 heads. That's everything else. So the odds are 3 to 5. I think that's the better way to write it. So, given the odds of a particular team winning a tournament is 3 to 5, it's the same odds here, what's the probability they win? Well, this is saying for every 3 they win, they don't win or they lose 5 times. So the probability will be n of a, where a is an event they win. Well, that can happen 3 times, divided by the sample space. Well, the sample space have 3 wins plus 5 losses. That's 3 over 8. which is exactly the same idea as we did up here. So I went from an odds to a probability. Earlier, I went from a probability to an odds, so I can work back and forth with these as I need to.